Hello everyone, this is Solubility and you're watching my YouTube channel. My dear friends, today we are going to discuss about another physical practical, the title of which you can already read out, and that is all about determination of solubility and solubility product of silver chloride AgCl by potentiometry. So it's obviously going to be an instrumental experiment. So let us first of all try to understand the theory and the procedure behind this experiment, and then I will take you to the lab for the demonstration of the experimental setup. Alright, so we begin with, when we need to determine the solubility and the solubility product of silver chloride. So the first point, my dear friends, you need to remember, and that is silver chloride, that is AgCl, is a sparingly soluble salt. Because that's the most important condition, my dear friends, that we can find out the solubility product of a sparingly soluble salt. Sparingly soluble का मतलब क्या होता है कि कुछ हद तक ही वो डिसॉल्व होगा, मतलब वो completely insoluble नहीं है, at the same time वो completely soluble नहीं है. यानी ये जो सॉल्युबिलिटी का प्रोसेस है वो स्लो है, और अगर वो प्रोसेस स्लो है तो इसका मतलब हो जाए कि वो रिवर्सिबल रिएक्शन. और दोस्तों, अगर रिवर्सिबल रिएक्शन होता है तो वी अप्लाई एन इक्विलिब्रियम कांस्टेंट. ऑलराइट, सो दैट इज व्हाट वी नीड टू थिंक अबाउट इट. अब जब हम सिल्वर क्लोराइड के बारे में बात करते हैं तो मैं आपको इक्विलिब्रियम रिएक्शन लिख के देता हूं. AgCl, okay, it's a reversible reaction जैसे मैंने बोला आपको, and it gives you Ag plus and Cl minus. अब दोस्तों, sparingly soluble salt का मतलब क्या होता है कि initially if I have, say for example 10 moles of silver chloride, then hardly 2 to 3 moles of that silver chloride will get soluble. For solubility, okay, it needs to undergo dissociation into Ag plus and Cl minus ions. यानी ये जो मुझे Ag plus और Cl minus ions मिल रहा है, that is corresponding to the 2 to 3 moles of AgCl which has dissolved in water. इसका दूसरा मतलब ये होता है कि the remaining 7 to 8 moles remains undissociated, the one which is not getting dissolved in water at a particular temperature. और जो स्टैंडर्ड टेम्परेचर हम कंसीडर करते हैं, दैट इज 298 केल्विन. सो दैट विल बी इन द फॉर्म ऑफ अनडिसोसिएटेड AgCl. नाउ इफ वी अप्लाई लॉ ऑफ मास एक्शन टू दिस, सो वी हैव K is equal to concentration of Ag plus into concentration of Cl minus divided by the concentration of AgCl. ये तो आपको मालूम है अच्छी तरीके से. अब मैं क्या करता हूँ, जो concentration of AgCl जो डिनोमिनेटर में है मैं उसको लेफ्ट में लेके जाता हूँ. अब जैसे मैंने बोला है कि concentration of AgCl is excess, undissociated form is excess, और जो भी substance दोस्तों excess में मौजूद होता है that is considered to be constant. K is already a constant, so a constant number multiplied by a constant number, it's obvious we get the constant answer, and that constant is denoted as Ksp, and it is known as solubility product. So Ksp for AgCl, we have an expression of concentration of Ag plus into the concentration of Cl minus. ठीक है? Now next thing is, हम ये जो experiment करने वाले हैं, that is according to instrumental technique, and that is potentiometer. तो जब हम potentiometer की बात करते हैं, obviously we are talking about the determination of potentials, okay, that is E cell. So we need to set up a cell. आपको मालूम है अच्छी तरीके से, when we set up a cell, cell representation, you have already learnt about it. Okay, so we draw a double vertical line, okay, which will divide the entire cell into 2 half cells. So what we do is, ये इसे double vertical line हम draw करेंगे in direct contact. This is going to be a salt bridge in this particular experiment. And then what we do is, we use saturated calomel electrode. Okay, and this is going to be negative. Next is on the right hand side, the positive electrode, and that is going to be, we are going to take KCl, okay, the concentration of which I will tell you in the due course of time in this particular experiment. Now this is being treated with 2 to 3 drops of silver nitrate, AgNO3, and a silver electrode is being placed, and this is going to be positive. Single vertical line means it's direct contact. So I have a KCl solution into which directly I am adding 2 to 3 drops of AgNO3. It gives me a precipitate of silver chloride, alright, and then it is being immersed into a silver electrode is being immersed into this. So they are all in direct contact, and the entire part is being connected to the positive terminal. I'll show you practically the experimental setup, okay, how we set up this particular experiment, okay, once I finish the theory as well as the procedure of this. Alright, so my dear friends, this is what is the introduction part. First thing is, for determination of solubility product, we need to take into consideration a sparingly soluble salt. Here we are going to take silver chloride, so it dissociates very slowly, reversible reaction into silver ions and chloride ions. We get the expression for KSP, and then we have set up a set where the negative electrode is saturated caramel electrode, and the positive is made up of a KCl solution of appropriate concentration, into which I am going to add 2 or 3 drops of AgNO3. That gives me a precipitate, white precipitate of AgCl, and into which I am going to introduce a silver electrode, and that silver electrode is being connected to the positive terminal of the potentiometer. So my dear friends, this is about the experimental setup. Now, as I said, that this part, okay, the double vertical line, it's going to be indirect contact, okay, and it's going to be a salt bridge. That salt bridge can be made up of ammonium nitrate, or we can take about KNO3. And the most important, the priority of this is to establish the ionic contact between the calamine and the silver electrode. Alright, my dear friends, so this is the most important requisite of a salt bridge. Why exactly the salt bridge is going to be used? Okay, first thing is, it is indirect contact, so we are not going to allow a direct contact between the two half shells, but at the same time, it's going to establish what? Ionic contact. Okay, which is so very important. So there is going to be migration of ions, there is going to be flow of current, and accordingly the potential of the cell can be determined. So it's going to establish the ionic contact between the two electrodes, that is calamine as well as silver electrode. Alright, so this is, my dear friends, the theoretical aspect of this particular experiment regarding solubility product of silver chloride. I hope up to this is very clear to you all. Yes, my dear friends, once we have understood the theory behind this experiment, now I'll explain you the procedure. My dear friends, two most important part which I feel is the important one with respect to the procedure, and that is, first one is preparation of the various concentrations of the KCl solution, and the second one is the experimental setup. Okay, the readings, they are directly going to be a readout device from a potentiometer, so you just need to watch it and note it down. But these are the two most important aspects: preparation of the solutions of the different concentrations of KCl and the experimental setup. Okay, so both of which I am going to explain over here, and as I said, I will take you to the laboratory and I will practically demonstrate that two important aspects. Alright, so we start with the preparation of the solution. Initially, the solution which is given to us as far as KCl is concerned is 0.1 molar. So I can call it as a stock solution as well. Okay, so preparation of solutions from 0.1 molar KCl. And that is, we are going to prepare 4 solutions. Okay, so serial number. Next is volume of 0.1 molar KCl, final volume in cm³, and then the concentration in molar. Okay, this is what we are going to consider. So 4 solutions, 1, 2, 3, 4. So we begin with first solution, volume of 0.1 molar KCl in cm³. I am going to take 50. Final volume is 100 everywhere. So that is going to give me 0.05. I am going to take 20. That's going to give me 0.02. I am going to take 10. That's going to give me 0.01. And I am going to take 5 cm³. And that's going to give me 0.005. Okay, so these are the concentrations. So what I'll do is, the stock solution is 0.1 molar KCl. I prepared out 50 cm³ of that in a standard measuring flask of 100 cm³. Okay, and then the rest I diluted with distilled water. Okay, I'm going to use distilled water for dilution. So that 100 ml of the solution now will have a concentration of 0.05. That's the first solution. Similarly, I'll prepare out 20 ml or 0.1 molar KCl and I dilute it to 100. It gives me 0.02. Next 10 ml diluted to 100. It will give me 0.01. And finally, I'm going to take 5 cm³ and dilute it to 100, and that will be 0.005. Okay, so this is the first important stage of this particular experiment, and that is accurately preparing the 4 solutions. Alright, so totally you have got 5 solutions now. One, obviously the stock solution of 0.1 molar KCl, and then from which you have prepared 4 other solutions. So that is 5 solutions. Alright, now what we do is we start taking the reading. So how to set up the entire experiment? So that is what we are going to consider. So what I do is I take 50 cm³ of the stock solution, that is 0.1 molar KCl, in a beaker. Generally you can take an amber colored beaker, because following which we are going to add silver nitrate also into this. So 50 cm³ of 0.1 molar KCl, we are going to take it in a beaker. Okay. Now next thing what we are going to do is we are going to add to this 2 to 3 drops of 0.1 molar AgNO3 solution, and we are going to insert the silver electrode and connect it to the positive terminal. Okay, of the potentiometer. Okay, and I've been telling you before as well, once again I repeat, whenever you have an instrumental experiment, please make sure that you standardize the instrument. You put on the instrument at least 10-15 minutes prior to your reading time. Okay, it's not you put on the instrument and then you start taking the reading. Just give the time of stabilization time for around say 10 to 15 minutes. Then you standardize the instrument and then you start taking the readings. Okay, so please remember this. So 50 cm³ of 0.1 molar KCl is being taken in a beaker. I'm going to add 2 or 3 drops of 0.1 molar AgNO3 solution and I'm going to stir it. I'm going to insert a silver electrode and connect it to the positive terminal. The saturated calomel electrode is connected to the negative terminal. Okay, and we are going to introduce a salt bridge. You know how the salt bridge looks like. Okay, it's an inverted U-shaped glass tube. Okay, so one arm will be in a beaker on one side, that is saturated calomel electrode, and the other arm will be in the solution of KCl and AgCl. Okay, so that way you are going to insert that. Alright, and then you are going to note down the reading and note the reading. Okay, next is replace 0.1 molar KCl by the various concentrations that we have prepared: 0.05 molar, 0.02 molar, one at a time, 0.01 molar and 0.005 molar, one at a time. Otherwise you will mix all the solutions. Okay, and repeat the procedure. Okay, which I have said over here. Okay, so replace this 0.1 molar KCl by the next solution, that is 0.05. Take around 50 ml because you have prepared all the solutions which are of 100 ml. Okay, so you take around approximately 50 ml. No need to exactly measure it. Alright, 50 cm cube, half a beaker, that's enough. Into which you add 2 or 3 drops of 0.1 molar AgNO3. It results in a precipitate, it becomes white in color. Okay, so stir it. Okay, and connections are already being done, so no problems with that. So only thing is you need to introduce once again a salt bridge. Okay, because you need to take the salt bridge out to replace one of the arms or one of the half cell. Okay, by a solution. So you introduce the salt bridge and you get the reading from the display. Just note it down. Alright, so this is the way we are going to note down 5 readings. First, of course, for the 0.1 molar and then for the various concentrations. Alright, so my dear friends, you have understood, I am very sure, with respect to what is the theoretical background of this particular experiment and what's going to be the procedure. Alright, now to make sure that you understand the experiment very well, okay, because readings, how to take the readings, for that the experimental setup is very important. So my dear friends, as I mentioned, I will now take you to the laboratory where I will actually demonstrate the experimental setup. Okay, I specify experimental setup. Okay, so that this experiment becomes very, very clear to you. So here we go, my dear friends, to the laboratory. Yes, my dear friends, welcome everyone for this practical session. In this particular session, we are going to discuss about the determination of a solubility product of KCl. Yes, my dear friends, when we are going to determine the solubility product of KCl, the instrument which we are going to use is potentiometer. I prepared a video which was respect to conductometer as well, and please remember that whenever we are going to carry out an instrumental analysis, please make sure that at least 10 to 15 minutes prior to you taking readings, the instrument should be on. Alright, so that you get errorless readings. So here we start. First thing is we will put on the instrument. So this is a potentiometer that we are going to use. And now I will slowly start with the other part. So in the meantime, it will take around say 10 to 15 minutes. So it is, the potentiometer is ready for giving us accurate. Alright, my dear friends, so we are now going to prepare 4 solutions from the given 0.1 normal KCl, which I have transferred into this particular beaker. What are those concentrations, my dear friends? First one is, I have labeled this standard measuring flask so that there is no problem as far as mixing of solution is concerned. So this is 0.05, this is 0.02, this is 0.01, and we have 0.005. All these are 100 ml solutions. Okay, that we need to prepare. So obviously you know very well, 0.1 is a higher concentration as compared to this. So we can decrease the concentration by increasing the dilutions. So we can prepare all these solutions by dilutions. So the volume is, first we start with 0.05. So it's half the concentration of the stock solution. So obviously the dilution has to be double. So what we'll do is, we'll take 50 ml of 0.1 normal KCl into this standard measuring flask and dilute it up to the mark with distilled water. See my dear friends, I have written over here distilled water. So that you know, there is no mixing of solutions at all because all the solutions are colorless. Alright, so we begin with, this is a 25 ml of pipette. So I'm going to pipette out twice. I'll just rinse this with distilled water. And now I'll take AgCl. So this is 25, one more time I need to whip it out. Alright, so this is 50 ml of KCl. In this I need to take 10 ml, 20 ml, 10 ml, 5 ml. So I take 20 ml. So this is 20 ml. Now next I need to take 10 ml.
Yes.
Okay, now we go for the next one is 10 ml. And finally now, the last concentration. And now finally, this is 5 ml. So my dear friends, I'll repeat the procedure again. I have 0.1 molar KCl, that is I call it as a stock solution, from which I am preparing 0.05. So how much I took? 50 ml. 0.02 I took 20 ml, 0.01 I took 10 ml, and 0.005 I took 5 ml. Now all these are 100 ml standard measuring flask. So I need to dilute all these solutions up to the mark. There will be mark everywhere in this standard measuring flask. So I need to dilute it up to the mark with what? Distilled water. Okay, so I will do the dilutions of all the solutions. So we need to hold it. This is the procedure, which of course you must be knowing it very well. Hold it to your eye level. So the mark is clearly visible. So in this way, you can see all these solutions are ready. 4 concentrations from the prepared 0.1 KCl. Alright, now what we have to do is, we have to set up a cell. For that, we are going to make use of a amber colored beaker. Okay, so in one of the beaker, we will be having the required concentration of KCl, to which we are going to add silver nitrate. And in the another beaker is going to be a secondary standard cell, which we also known it as saturated calomel electrode. So that will be the secondary cell, and then we will connect it to the potentiometer. Okay, now we start with the readings. We are going to take 2 amber colored beakers. One of them is filled with the secondary reference electrode, that is saturated calomel electrode. So this is a saturated calomel electrode. The other one is going to be a silver electrode. Okay, now this silver electrode is being connected to the positive terminal. The saturated calomel electrode is being connected to the negative terminal. Now what is the silver electrode? Now what we have done is, we have taken first of all the lowest concentration of KCl solution which we prepared, and that was 0.005. So I taken around approximately 50 cm of that, introduced the silver electrode. This is a salt bridge. Alright, so this is what the setting is. Now I will be adding few drops of silver nitrate solution into this, AgNO3 into this. So you can see there is a formation of a precipitate also. Silver nitrate and KCl gives you a precipitate of Ag.